welcome to Christ Open Courseware. In this video, we will be seeing the data structure Q and its various operations, representation of Qs with the help of array and linked list. Now, what is a Q data structure? Almost everyone in your life will be standing at least in one queue. So, what is happening in a queue? You are going from the back, you stand in a queue, and when your chance comes, you take whatever you want or you do whatever you want and you go out of the queue, right? So this is the same process we will be doing in the data structure queue itself. So let's take a figure. Suppose this is the line and you enter through this portion. Naturally, this portion is called the rear part, rear of the queue. You enter through this way. So suppose, let's say this is a counter for selling tickets. You enter through this way, you go to this place. This is the first person, this is the second person, this is the third person, and this is the fourth person. So naturally what happens here is when the first person's job finishes, he goes through this way, and this is naturally called friend of the queue, right? So after the first person goes, naturally the second person comes forward. When the second person goes, third person comes forward. When the third person goes, the fourth person comes forward, right? So all the people enter to the queue through the rear portion and they go out of the queue through the front portion. So what happens here is, naturally in queue data structure we use the same concept. So let's say with the help of an array, if you are implementing queue with the help of an array, suppose this is an array of size 5. So naturally we will be inserting elements. So let's say this is 10, 20, 30, 40, 50, right? So first element is index 1, 2, 3, 4, 5. Now, how can we place the rear and front of this queue? This is an array A. So I say this is the front and this is the rear. Okay. So what happens here? Beginning 10 becomes the first element. Next 20 becomes the first element. Then 30. Then 40. Then 50 the last element, right? So 10 is the first, 20 is the second, 30 is the third, 40 is the fourth, 50 is the fifth element, and naturally rear will be pointing to this portion. So what happens when all the insertion happens with the help of the variable rear? That is what happens here. We can see when rear is incremented, the push operation or NQ operation or insertion operation happens in the queue. Now what happens if you want to delete? Deletion means you have to deal with the variable friend, right? So friend, first deletion in this queue becomes you eliminate the first variable 10, right? Now friend naturally will be pointing to the next variable 20, right? Now friend is pointing to the next variable 20. So what happens here is friend is plus 1, friend also increments. So naturally deletion happens through this end, insertion happens through this end. So how can we find say the definition of queue? Queue is a data structure, a linear data structure. Queue is a linear data structure like array and stack and linked list. And what is operation happens only at either of the two ends. What are the two ends? That is the front or the rear. Rear for insertion, front for deletion. Okay, so But in stack, what is the concept in stack? Both in one end called the top. Here you have two ends, front and rear. Insertion happens through the rear, deletion happens through the front. So that is the difference between queue and stack. In queue you have two ends, one for insertion for one end and deletion at the other end. But in stack you only have one end for both purpose, for both insertion and deletion. So queue is a linear data structure like array, linked list and stack, and operations are done either one of the ends. For insertion you do it at the rear part, for deletion you do it at the front part, right? Now similarly, as we have seen in stack, queue also can be represented using representation of queue is done with the help of array and linked list. In this example which I have given here to now, I have done with the help of the array, right? Linked list we can see. Now what is happening here in array? Starting from the index 1 and 5, that means n is equal to 5, right? Now let's see some of the conditions here. So when the queue is empty, what does means? Front equal to 0 and rear equal to 0 means the queue is empty. Now suppose the queue is full. So I have now deleted this. Now what is the value of front here? Front is equal to 1 and rear is equal to 5, right? So size n is equal to 5. Now what does this imply? The queue is full. Now that is the condition here. When queue is full, front is equal to 1 and rear is equal to n. Now next condition, what's it? Queue contains elements greater than or equal to 1. That is, the queue contains at least one element, but the queue is not full. So what does that mean? In that situation, front is always less than or equal to rear, right? Suppose we don't have element, the size is 5 itself, but we have only 3 elements, right? Now naturally at this situation, rear will be pointing to the last inserted element, that is 30. So let's see. Now what is the situation here? Here front is equal to 1 and rear is equal to 3, right? So how many number of elements can be found? The number of elements here will be 3 minus 1 plus 1, that is 2 plus 1, 3, right? So that means when the queue is not full, you will have front as 1 itself, rear will be the last inserted element, value of the last index of the value last inserted element, and that is 3 here. And the number of elements can be found with the formula rear minus front plus 1, that is 3 minus 1 plus 1, and that will give the number of elements. In this example we have already 3 elements, right? Next we can see the representation of queue in the linked list. In linked list representation, I am using the concept of double linked list, since we can traverse in the both ways. Okay, let's see with the figure. We have first naturally a header node. Since I am using the double linked list, naturally the header portion data part is empty, left link of the double linked list is null, and right link should contain a value. Let's stay there. We can draw the other nodes. Suppose 20 is the first element, 30 the second element, 40 the third element, 50 the last element. Since 50 is the last element, I have the right link of this node as null, and as we have seen in earlier videos of double linked list, we can traverse in both ways. That is, we have the left link and the right link. Right link is used to go forward and left link is used to go backward. right? So in this figure, the first node 20 represents the front, and the last node 50 represents the rear. Okay, so first you insert the first node 20, then the next node 30, then the next 40, and last the 50, and right link portion of the last node will be naturally none. Now let's see some of the conditions. When Q is empty, what are the conditions? The first condition is front and rear is equal to header. So if Q is empty means don't consider this portion. So if Q is empty, you only have the header node, right? So let's cancel it. There is no data portion. Naturally, sorry, the left link is null. The Q is empty means right link is also null, right? And moreover, the front and rear is pointing to the header. Front and rear will be pointing to header. Right link of the header node is also none because the queue is empty. Now what happens? You have at least one element. Naturally the R link will not be equal to null. So if R link is not equal to null, the right link of the header node is not equal to null, that it implies you have at least one element. So this is how we can represent Q with the help of linked list and with the help of array. In linked list, we have taken the concept of double linked list so that we can go forward and also backward. The first element is represented by the front variable and the last element is represented by the rear variable. Similar with the concept of arrays. Okay, next we will see the operations in Q using arrays.